resolving the contradictions of contemporary science. And that includes cosmology and quantum mechanics and everything that we consider science today. Everything that we consider science today. And that includes physics, biology, chemistry, mathematics, and everything else. So before I even start, I just wanted to know that we are going to be a little long today. I'm going to be a little long today. And what I am going to suggest today, what I'm going to talk today, may not be appealing to you at all. In which case, feel free to kind of tune out, and that's okay. That's totally okay. Feel free to tune out. It's totally okay. Many of you, especially my critics and skeptics and cynics, will, of course, roll their eyes up as I talk about what I'm going to talk about, and refer to it as pseudo-profound bullshit, pseudoscience, quackery, etc., etc. But let's not worry about that. I feel the need right now to share these insights with you. I think our current science, when it is dogmatic and closed, actually hinders our understanding of reality. I've mentioned before that our current science is based on something called naive realism, and I'll address that as well. So why do I offer this as a general theory of reality? I offer this because it does resolve what I call the contradictions of contemporary science. So going back to the history of the scientific revolution. The scientific revolution occurred about approximately 500 years ago. And when we think of the scientific revolution, we think of names like Isaac Newton and many others, Michael Faraday, etc. And, many European scientists, predominantly European in the last 300 years. But classical mechanics began with Isaac Newton, who, as I told you yesterday, I think, or day before, also believed in the literal interpretation of the Bible. But he did come up with the laws of mechanics. And then around that time, there were other laws being discovered, thermodynamics, and they became the basis of the Industrial Revolution. And then about 100 years ago, we had two other major revolutions in science after Newton. The first was special theory of relativity. The second was general theory of relativity, both Isaac Newton, so we can say the theories of relativity. And then also the theories of quantum physics and quantum mechanics, which were about the microscopic nature of what we refer to as objective reality. But along with these theories came many contradictions, many paradoxes, and many conundrums. And I want to begin by sharing some of the conundrums that came along with these theories, even as I describe these theories. And then if you hang in there, I'll tell you what the conundrums are and what they can be, how they can be resolved. So somebody is correcting me, saying Einstein, not Newton. Maybe I made a mistake, but going back, Newton, classical physics; Einstein, relativity; Niels Bohr, Schrödinger; Paul Dirac, Max Planck, on and on, Wolfgang Pauli, and Heisenberg as the quantum pioneers. So that's the sequence, Newton, Einstein, quantum pioneers. So now let me go over some of the principles. I'm doing this for completion. I'm also hoping this one of you, or maybe more than one of you, will transcribe today's talk, because I'm hoping to publish a peer-reviewed paper on this, and also hoping to create an essay for the general public for publication, and ultimately maybe even a book out of this, A General Theory of Reality, Resolving the Contradictions of Contemporary Science. So I'm doing this today for myself, but also to share with you, to get your feedback, to seek your help. Maybe you can do a transcription, and maybe at some point this can become an essay for the general public, a paper in a professional journal, and also possibly a book. Okay, enough. Now let's go over the sequence. I'm not going to talk about Isaac Newton right now. We've done it before. Let's start with Einstein. So at the age of 26, Einstein published about 5 papers that shocked the physics community and drastically transformed our view of the universe. Very interesting. Our view of the universe. Doesn't say this. I looked up this online. It didn't say our knowledge of the universe. It said our view of the universe. I like that. Okay, so let's talk about the first theory, published in 1905. And if I were to summarize the basic tenets of the theory of special theory of relativity, they are basically 3. Number 1, moving clocks. A clock on a spaceship moving at lightning speeds, or close to lightning speed. Moving clocks move slowly, which means the faster the clock moves, slower the time. Moving clocks move more slowly than stationary clocks. Second, moving objects. This is an object. This is an object. Moving objects are shortened in length in the direction of their movement. So length is not fixed. It depends on how fast you move. So if you move extremely fast, then the object becomes smaller and time becomes slower. That's second principle of special relativity. Pretty weird when you first think of it. Number third principle is the order of events is not absolute. So something for one observer can be in the future, for another can be in the past, for a third can be in the present. In all frames of reference, the speed of light remains a constant. However, the order of events, past, present, and future, is not absolute. It can vary. Pretty wild. And then, of course, a derivative of Einstein's theory is the equivalence of mass and energy. Mass as the same thing as energy. The famous equation, E is equal to mc squared. So you can see right there that the special theory of relativity changes the way we experience reality. Length is not fixed, time is not fixed, the order of events is not fixed. Material objects have energy inside them. The energy can become matter, matter can become energy. Pretty wild. Okay, not what the world appears to be from our everyday experience of reality as we walk about the streets of New York or San Diego or Calcutta. Okay, so that's the special theory of relativity. Then there is something called the general theory of relativity, which was published about 1915, I think, although apparently Einstein worked on it throughout that period between 1907 and 1915. Unlike the special theory of relativity, the general theory of relativity is completely different, okay, and it does not agree with the theories of quantum mechanics. So if we were to summarize the general theory of relativity, one sentence would do: gravity is a warping of space-time through interaction between masses. So essentially, gravity is the curvature of space-time, of the fabric of space-time. The famous John Wheeler, a contemporary originally of Einstein as well, who died only a few years ago, Princeton University, great physicist, is quoted as saying, "Space-time tells matter how to move, and matter tells space-time how to curve." Okay, and this general theory of relativity introduced the concepts of what people call frame dragging, black holes, and gravity as well. And so this is an amazing theory because now gravity waves have been identified. We know that black holes exist, and these theories have given us a new picture of reality, including the fact that time slows down, and depending on the what do you call it, the density of matter, and as it increases, time slows down. So if you're say at the event hole of a black horizon, and somebody is looking at you from the outside, theoretically, and you're trying to enter the black hole, it takes eternity for you to go from the event horizon to the black hole, which is the singularity. In other words, you don't seem to move at all. But if you were an observer from the inside of the event horizon, what takes eternity takes less than a fraction of a fraction of a fraction of a fraction of a second. The observer from the event hole disappears into the singularity before you can say Jack Robinson. So it depends where you're observing the event from. And of course, for the observer themselves, as they go through the event horizon, the laws of mathematics say that nothing seems changed. It seems like every day, every experience. So the general theory of relativity is also pretty weird, but it explains lots of things: black holes, singularities, the gravity as a warping of space-time by mass, and also the fact that space-time, gravity, and are all interrelated. And from this comes everything that we call the physical world. And towards the end of his life, Einstein was very focused on actually finding a solution to what is called the unified field theory. So what is the unified field theory? The unified field theory is an attempt by Einstein to unify the forces of gravity, electromagnetism, and quantum mechanics. Unfortunately, he could not do this because gravity, the laws that govern gravity, general theory of relativity, do not match the laws of quantum mechanics. And so these forces of nature, electromagnetism, strong and weak interactions, gravity, cannot be unified mathematically or by any theory of physics. So that was a big problem. And then, of course, there came quantum mechanics, which further confounded everything. So in quantum mechanics, for the first time, we actually see that there is no certainty. So one of the big things about quantum mechanics is the uncertainty principle. Fundamental levels of nature, the position of a particle, the momentum of the particle cannot be known at the same time. And so it cannot be known at the same time. And there is an element of uncertainty. You can either know the position of a particle or the momentum, but not both at the same time. And more you know about one, the less you know about the other. So if I ask you, where are you? You can say, I'm in Timbuktu. And then I ask you, what are you up to? And you say, I'm not telling. Or I can ask you, what are you up to? And you're saying, have a party. I'm at a party. And then I say, and where is the party? And you say, I can't tell you. So the element of uncertainty arises. And then many other things, superposition, entanglement, and wave-particle duality. It gets pretty strange, and it keeps getting stranger and stranger till it gets so strange that it gets stranger not only that we think it is, it gets stranger than we can think. Okay? It gets stranger than we can think. Bottom line, quantum physics does not agree with general relativity, the cosmological theories of the universe at a big scale. Quantum physics doesn't agree with that. And what special theory tells us is true also. What mass energy equivalence tells us is also true. What special theory tells us about the nature of time and the nature of ordered events, all these things seem to be true when you follow the theory, but then the theory doesn't explain what the other theories explain. So special theory doesn't explain general theory doesn't explain quantum mechanics, and therefore there are a lot of contradictions, and there are a lot of paradoxes and a lot of conundrums, as we say, in our current science. And what I'm saying to you today is actually there's a solution. There's a solution to these cosmological conundrums. And before I get into that solution, I just want to make sure, so far, are you following me? Are you following me so far? And is this even interesting to you? And I'm just looking at your feedback, and then I'm going to start continuing. I'm going to start continuing on how to resolve these contradictions and paradoxes and conundrums. And before I do that, there was one thing more that I wanted to share, and I would say that is a relook, just for a moment, at what we call naive realism. Okay, because all these theories, including quantum mechanics and including special and general relativity, and I would say, except for certain exceptions, mathematics and Gerdes' theorem, these theories are based on naive realism. And so I wanted to just go over some of the basic tenets of naive realism, which is the basis of all science, and particularly the fact that despite his genius, Einstein was really a naive realist, and most scientists are, even today. So what is naive realism? Naive realism, I couldn't find my notes, but let me just go over the basic principles of naive realism. Number one, the world is physical, made of matter. Problem? No one has ever seen a substance called matter. We only experience our perceptions. Furthermore, the nature of matter becomes very elusive. As you go down the rabbit hole, matter becomes atoms, molecules, wave particles, and ultimately disappears into mathematical space. So the assumption of science that the world is physical could be a wrong assumption. Number one. Number two, it's based on subject-object split, naive realism, which means the subject of experience and the object of experience, the subject of experience are two different entities. But actually, the subject of experience and the object of experience are a unified experience in awareness, and both the subject as a body-mind and the object as an object both of them are simultaneously appearing in awareness or consciousness. And they're made of the same stuff, whether you look at it from a material perspective or a non-material perspective. This is made of atoms and force fields and particles, and so is this. So subject-object split is artificial. That's the second objection to naive realism. The third principle of naive realism is that the world, physical world, is exactly as it appears to the five human senses. Obviously not true, because other biological species have other senses, so the physical world would appear different to them. Fourth objection to naive realism: the physical world as it appears to the five human senses would exist even in the absence of any sentient beings looking at that universe. The objection to that is, how do you know? How do you know that the physical world exists before you have any experience of the physical world? So this is also an objection to naive realism. And yet all our science and technology is based on naive realism, and it seems to work. It seems to work. Okay, there's another big problem in today's cosmological understanding of the universe, and it's called the cosmological constant problem. And this is about the fact that the cosmological constant refers to really the disagreement between the observed values of the quantum vacuum, the fundamental ground of existence, between the observed values of the quantum vacuum and the mathematical, theoretical large value of what is called the zero-point energy field. So the quantum field theory predicts a value that's hugely large, 1 to the power of something like 120 times orders of magnitude than the observed value. So, that's a huge, it's also referred to as the cosmological problem, or the cosmological embarrassment, or the cosmological disagreement, and nobody knows how to address it. So see how many contradictions and paradoxes there are. Classical physics doesn't agree with quantum physics. Quantum physics has 35 or 30 interpretations. Quantum physics doesn't agree with general theory of relativity, which is totally different from special theory of relativity. And then we have, of course, all these different principles or modalities of science: physics, chemistry, biology, mathematics, geology, astronomy, on and on. All of them, by the way, are based on naive realism. So that's why we have the problem. Naive realism is not realism. Naive realism is not realism. But let's go there a little more slowly, because what I'm going to share with you right now is a very important aspect of our new theory, which is a general theory of reality. So let's start with me trying to solve these problems right now with you, and I'm seeing that you're still there, and so that is very encouraging. So before we come up with a theory about anything, okay, before we come up with a scientific theory, mathematical theory, theory in physics, biology, before we come up with any theory, we must have some experience and some knowing that we need to explain. So prior to the construction of a theory is some experience. And that experience is a form of knowing. The form of knowing can be the interpretation of a perceptual activity, or it could be a mathematical knowing, a theoretical knowing. Einstein presumably was riding on a beam of light in his imagination when he came up with the special theory of relativity. Okay, but let's agree on one simple thing. Please, let's agree on one simple thing, and that is that before you come up with a theory, you have to have an experience and a knowing. And that experience and the knowing is in consciousness. Okay, where else could it be? Any experience and any knowing, any theory, first has to come up with an experience, and then the interpretation of the experience. The experience is a perceptual activity, and the interpretation of the experience is a mental activity. So theories are based on modes of knowing and experience. All theories. Right? But the way philosophy is based on that, theology is based on that, mythology, even gossip is based on modes of knowing and experience. And in every experience, there are three components to the experience. There's the observer, there's the process of observation, and there's that which we call the observed. Okay. I'm just getting a cup of coffee. So in every theory, or every experience, there's the observer, the process of observation, and that which is observed. We can also say knower, process of knowing, and that which is known. And so let's look at these three components. I'm just checking to see if you guys are still there. Okay, yes you are, and thank you for being there. Hang on, we're going to come up with an amazing solution to the current scientific dilemmas. Okay, so every experience has those three components: observer, process of observation, that which is observed; knower, process of knowing, that which is known. So let's take all these three components. The first is, who or what is the observer? And to simplify it, I will say that the observer is invisible. That which is observing the body, that which is observing thoughts, that which is observing the world is invisible. We cannot see the observer because the observer is seeing. We cannot observe the observer because the observer is observing. Okay, we cannot perceive the observer because the observer is perceiving. The observer is invisible, and the reason the observer is invisible, it doesn't have a form. Invisible doesn't have a form. That's exactly what the word means. Not having a form, it's infinite because it has no boundary. Okay, so the observer is infinite, formless, without cause, doesn't have a shape or a color, can't be heard, can't be seen, can't be touched, tasted, smelled, sensed. Only is there in every observation as the invisible, formless, timeless, infinite observer. You are that, I am that, everything else is that. But of course, we are still different observers, okay? Based on conditioning and all of that. Bottom line, observer is invisible. Now, the observer, second aspect of experience is observing, seeing, hearing, feeling, thinking, all of that. Okay. So, the observing is a process. And observing is also the activity that we call a biological organism. So what is a biological organism? It's a modified activity of the observer. The observer modifies itself into the act of observing. The seer modifies itself into the act of seeing. The thinker modifies itself into the act of thinking, etc. Okay, seeing, hearing, sensing, thinking, feeling, all that is the act of observing. But the biological organism itself is an instrument of observing, modified from the observer. This biological instrument is very different from the biological instrument that we call a giraffe or a butterfly or an eagle or a dolphin. So, depending on the instrument that the observer is using, what appears as the observed is different, right? What appears as the observed to a giraffe is presumably what appears as the observed to an eagle in the sky, or to a dolphin, or an insect with 100 eyes. So depending on the instrument of observation, which is the activity of the observer modified into observing, what is observed is completely different. There's no such thing as a fixed object out there. No such thing. This is the echo of ultrasound to a bat. Okay. I don't know what this looks like to a chameleon because its eyeballs swivel on two different axes. I don't know if a butterfly would sense this through what? Ultraviolet. This is just a human experience right now, and a human construct as a microphone. So we can see that the observing is not only species specific, but it's also culture specific. You know, what would this mean to somebody in the age of Neanderthals? Nothing. Okay. The instrument of the observation is also a modified form of the observer. And in humans, that's not only culture specific, but it is person specific. Look at my hand, and as Anup Kumar was saying the other day in his video, the hand I am seeing is not the hand you're seeing. I'm seeing this part of the hand, you're seeing this part of the hand, and then depending on where you're looking from, you're having a different experience of the hand. Or where you are in your room right now, depending on where you are, it's the same room, but it's not the same room as an experience, depending on your location and what you're looking for as well, right? So this leads us to human observations, which involve many things. So human observing involves not only the biological organism, but all the prostheses that this biological organism can use to extend its range of observation, from microscopes to telescopes to particle colliders, and also the questions that are being asked by the human observer that determine what is being observed, right? Is it a wave? Well, let's do a wave-like experiment and we'll see a wave. Is it a particle? Let's do a particle-like experiment and we'll see a particle. So actually, everything that we observe determines how we observe it. What you observe changes depending on how you observe it, and also the questions that the observer is asking. They determine that which is observed. In other words, modes of knowing and experience expressed by humans in language determine that which is observed. Language. What is language? Language is a description of experience. So language describes experience, but as we'll see in a moment, language also constructs experience. Language describes experience, but also language constructs experience. Oral language, 30, 40, 50,000 years ago started. Written language, maybe 5,000, 10 years ago it started. And now, of course, we have so many languages. We have musical language, body language, language which is verbal, mathematical language. And language is basically a story given to an experience. And language started with gossip and then became mythology and religion and philosophy and science. And then science became physics and chemistry and biology and botany and zoology and mathematics. These are all languages. Okay? So what we call the scientific method is a language for not only describing reality, but constructing a certain experience of reality. So these are different languages. Mathematics is also a language. And what are they describing? They're describing modes of knowing and experience. They're all descriptions of experience, but they also, as they describe, they construct the experience in terms of human modes of knowing. What is known appears different, even contradictory, in different modes of knowing. Now, there's one theorem in mathematics called Gödel's theorem, which you may or may not know about, but Gödel's theorem is also referred to as the Gödel's incompleteness theorem. And basically what it says is that in a sequence of mathematical logical principles in a theorem, there is always one theorem that cannot be proved. Okay, that's an assumption that at a certain point in the logic of mathematics, the logic cannot proceed. The mathematician is stymied till he suddenly or she suddenly gets an insight and says, "Oh, I can't prove that theorem, but it seems to be true." And if they assume that it seems to be true, then logic proceeds. In other words, even mathematical logic is interrupted by discontinuity, which means there's a break in the logical thinking. Now, I happen to think that's an indication of the creativity inherent in the laws of nature, that they are logical, but at some point there's a gap in the logic and a creative leap in logic, which leads to sequential mathematical logical reasoning, mathematical again. Okay, so mathematics, physics, chemistry, biology, geology, astronomy, they all reflect different modes of knowing and experience in different languages. And the language then gives us not only the mapping of the experience, but it gives us a description of the experience, but it actually also constructs the experience. So the mathematical logic constructs a different experience than the logic of classical physics or the logic of Newtonian physics or quantum mechanics or anything else that we want to think about. In other words, it is the states of being and states of awareness and states of knowing and states of experience that construct the logic, scientific or otherwise, that determines the constructs, the theories that shape our interpretation of reality and also the experience of reality. And it is very obvious that the physical world somehow corresponds to the biological instrument that is observing it. We've addressed that before, but we can also say that the physical world corresponds, the experience of the physical world corresponds to the state of awareness of the biological apparatus and its prostheses that are looking at it and the questions being asked. Okay. So what you're looking at is different when you're awake. It's different when you're drowsy. It's different when you're dreaming. It's different when you're close to deep sleep. It's different in anesthesia. It's different when you have a head injury. It's different when you are drunk. It's different when you take psychedelics. It's different when you have love. It's different when you have fear. Your state of biology determines the perceptual activity that you call the physical world. Okay, it's obvious that biological processes and the experience of the world, perceptual experience of the world, are entangled. And not only are biological processes and the state of the world entangled, the state of biology, which constantly shifts from moment to moment, in every biological organism actually determines its experience of the world. And in humans, it determines the interpretation. So we are very, very interesting creatures. We have all we are experiencing is what other animals and species are experiencing. What are they experiencing? Perceptual activity. Is their perceptual activity different from ours? Yes, with overlapping entanglement, but it's different. The perceptual activity of a butterfly is completely different than the perceptual activity of a horseshoe crab or you or me. Okay, so what we call the physical world is a changing experience of perceptual activity, including the physical body. And furthermore, the instrument of observation is constantly changing depending on the state of the awareness of the observer, right? So, if you really have followed this logic, let me know if you have. If you have followed this logic, please let me know. If you have followed this logic, then you'll realize that there is no such thing as a physical universe. There is no such thing as a physical body, and there's no such thing even as a mind. Mind itself is a construct. What is not a construct? Anything we have a word for is a construct. So everything is a construct. Everything we experience is a construct. Is there something that is not a construct and yet we can name it? And the answer is yes. That something is pure consciousness. We can give it a name, but it's not a construct. It's the source of all constructs. Okay. So what is reality before it becomes a construct and an experience? That reality, we've said many times, is formless, timeless, spaceless, borderless, without cause, unfiltered, unfettered, infinite, invisible, shapeless, inconceivable, unimaginable, but the source of every experience that we call reality, mental or perceptual. That is not a construct. Okay, even though we can give it a name. We can give it a name, pure consciousness, that is differentiating itself into innumerable modes of knowing, innumerable knowers, and innumerable objects known, all within itself. So, these innumerable modes of knowing, they're so innumerable that we can call them infinite. We cannot count them. There is no objective physical reality. It's an illusion. It's a construction. And that includes stars, galaxies, space-time, force fields, atoms, molecules, particles, waves. All are constructs. They're constructed, conceived, governed, come into existence in our being. Who are you? You're an infinite being, timeless and irreducible and without cause, without shape, without color, completely formless. And where is science going? It is going in the direction of the death of naive realism. Matter is not the ontological primitive. Reality is independent or prior to subject-object split. The physical world is a perception. The human physical world is a human perceptual activity. It does not exist in the absence of that perceptual activity. The world is as perceived by the perceiver, and the only reality is the formless, is the invisible. That's the real reality. And when we understand this way, or open this way of thinking, we can see that we can have freedom from death. Can we have freedom from pain? No. Pain is part of the experience of infinite possibilities. Can we have freedom from suffering? Ultimately, we can by knowing that both pain and its opposite, pleasure, are complementary aspects of something that is eternally free. So yes, we can have freedom from suffering, freedom from the construct of death, freedom from being bamboozled by constructs while using the constructs to create a better experience of reality. But the experience of reality is not fundamental reality. Fundamental reality is that which gives rise to the experience of reality. So the only reality is ultimately infinite and without cause, inconceivable. Every attribute, every quality we give to the world is a reflection of a state of awareness, therefore a reflection of the state of awareness, which is a modified expression of being. And what we call being, fundamental, invisible, eternal, infinite, is constantly fluctuating as states of being, which determine states of reality. And these are qualia states, shifting qualia states. Qualia means quality of experience, creating, shifting, recycling, evolving reality. There's no contradiction here. Cosmological constant, difference between observed value and theoretical value is a difference between one state of knowing and another state of knowing. Difference between the classical world and the quantum world is one state of knowing and another state of knowing, all in waking state of consciousness. Okay, the different interpretations of quantum physics, different modes of knowing and interpretation in human consciousness. Everything that I mentioned as a possible contradiction, possible paradox, possible conundrum disappears when you realize that there's no objective world, there's no objective body, there's no objective universe. There are only modes of knowing and awareness and an infinite knower. And even the local, so-called local knowers, the Deepak Chopra knower, the Paul Smith knower, the Linda Johnson knower, the name, that particular entity itself is a mode of knowing and experience, giving a species-specific, culture-specific, individual-specific experience of knowing that we call the physical world. But there is no such thing. The only reality is you. Without you, no mode of knowing, no mode of experience, no arguments about reality, no debates, no views, no God, no devil, no universe, no nothing. In that knowing of nothing is the knowing of everything. Today's contemporary science is a very useful map for navigating the experience of everyday perceptual reality. Period. But today's science does not explain existence or awareness of existence, because existence, awareness of existence, and all explanations of existence are in you. You are the universe. You are metahuman. That's amazing, isn't it? Absolutely amazing. We can continue on this. I will hopefully get some notes on this, and then we will continue the journey. And tomorrow I'll pick up also on infinite love, moving from the last topic, which was infatuation, to the next stage of love, which is communion. soul to soul connection. So I hope this made sense. My friends, did this make sense? This is an amazing Sangha, all of us together, making a difference in our creation of reality. Very good feedback, and there's some resonance here. To be continued.